Hello, so it's another video on graphs. Can you match these four graphs to their equations? Pause the video, have a think and click play when you're ready to check. Did you get it right? You should already know that this is a straight line because the highest power of x is 1. And this positive quadratic x squared is a U-shaped curve. And the x cubed is a cubic, and so it looks like this. So then, by default, this equation must go with this graph. These are known as reciprocal functions, a number divided by x, and these are the reciprocal graphs. You may be thinking, why do we care about reciprocal functions? But actually, they're really important. Starting with Isaac Newton, he deduced that the forces needed to hold planets in orbits is a reciprocal relationship with the squares of their distances. So, as the distance between two planets increases, the gravitational force decreases. Other examples are radioactive isotopes decay reciprocally, and trees losing their leaves. So going back to the graphs, why do they split into two separate parts? Let's have a look at y equals 1 over x in more detail. So we have our table of values, and if we substitute in these x values into y equals 1 over x, we get these values. See how as x gets smaller, so closer to 0, the y values get bigger. This means that when x gets really close to 0, y would be very large. Impossible to write a number so large. So then for when x is actually 0, you can't divide by 0, there is no value. The graph gets closer and closer to the y-axis, but it never touches it. The graph also gets closer and closer to the x-axis, and also never touches it. This is the same reasoning. If we rearrange the equation, it would be x equals 1 divided by y. And again, you cannot divide by 0. Just on a side note, notice how the graph has two lines of symmetry. So from this video, you should know that reciprocal graphs look like this. They bend towards a horizontal and vertical line, but they never quite touch it. So the shape always stays the same, but it could be shifted, and a negative reciprocal looks like this. So you should now confidently be able to recognise a straight line, a quadratic, a cubic, and a reciprocal function. Bye!